Hi friends, let's start by learning what is work. So when you hear the word work, what comes to your mind? When we hear the word work, we might think of our father going to the office, or when our mother cooks food for us, or maybe when we clean our houses. So this means work. But then let's look, what does work mean in physics? Work is the product of force and displacement caused by the force. So work is the multiplication of force into displacement, which is caused by the force, is equal to work. So we can say that work is equal to force into displacement. Now let us look at an example. The boy over here is putting force from the initial position of the box to the final position, which is the displacement. So over here, the work done is equal to force into displacement. Okay friends, now let us look, when is work 0? Okay friends, now let us take an example. Over here, SpongeBob is trying very hard to push the wall. He's putting his full force to push the wall, but he is unable to push the wall. Even if he puts 100 Newton or 200 Newton, he won't be able to move the wall. So over here, work is equal to 0 because there is no displacement. SpongeBob might put 500 Newton force, but then he is unable to move the wall, which means there is no displacement. And as we know that work is equal to force into displacement, so over here there is 500 Newton and the displacement is 0. So when we take the formula work is equal to force into displacement, we will write 500 Newton into 0 displacement, which will be equal to 0. So over here work is equal to 0. So if we want to define work in physics, there must be force and displacement, not only force and 0 displacement. Guys, remember work is a scalar quantity. Now let us look at the SI unit of work. The SI unit of work is joule. The CGS unit, which comes in centimeter, gram and seconds pattern, the CGS unit is erg. And always remember that 1 joule is equal to 10 raised to 7 erg. Okay guys, now the next point is that work can be positive. So over here the force and the displacement, they are in the same direction. So that's why it is positive. So work can be positive. Okay friends, now work can also be negative. Now let us understand how can work be negative. Let's take an example. This man throws the box up. So when the box goes up, that is the upward displacement. That's the displacement happening. Now what is happening down? The gravitational force is pulling the box down, due to which the box comes down. So when displacement and force acts in opposite directions, the work is said to be negative. And over here, when the man throws the box up, the displacement is up and the gravitational force, which is the force, it is pulling it down. So it is opposite. Okay guys, now let's see what is energy. Energy is the capacity or ability to do work. Now when you do some work, you need to put force to do that work. You need to have energy to do the work. Now let's take an example of these workers. They're pushing the box, they're putting energy, they're putting force and pushing the box to deliver it to the customers. So this is energy, the capacity or ability to do work. So guys, one more point is that energy is equal to work. Why? Because the amount of energy produced, that much work will be done. For example, X amount of energy, I produce X amount of energy. So X amount of work will be done. So as much energy is there, that much work will be done. So energy is equal to work. Now the SI unit for work is joule. Okay friends, now let's learn the two types of energy, which are kinetic and potential energy. The energy which is in motion is kinetic energy. Now this car is in motion, so it is kinetic energy. The energy which is possessed by its weight or position and is in rest is called potential energy. Over here, the rock possesses potential energy because it's in rest. Now when the man pushes the rock, it changes from potential energy to kinetic energy because it slides down in motion. So this is kinetic energy.